Greetings, this is Unit 6, Module 1, Session 3. The name of this home connection is Fraction Stories. Two-pager, name and number please. Susie wants to make some hot cereal for breakfast. The directions say to use 3 cups of water with 1 cup of cereal to make 4 servings. But Susie only wants 1 serving. So if she takes 3 cups of water, so we'll say, like, here would be a cup of water, here would be a cup of water, here would be a cup of water, and then here would be 1 cup of cereal. That altogether will feed 4 people, but she only wants enough for her, right? So that's too much water and too much cereal. So we have to figure out, well, how much of each should she have? Personally, what I think we should do is maybe look at this 1 cup first, because we said this 1 cup will serve 4 people, right? So that means each person would need 1/4 of it. What do I mean by that? 1 cup of water is needed for the recipe. That 1 cup is, cereal. Oh, my goodness, I've been saying the wrong thing this whole time. This 1 cup of cereal, when you cook it with the water, will feed 4 people. But if you're only going to feed 1 person, then I can cut that cup into 4 pieces, and then each individual person would only need 1 cup of cereal. Okay? And then she's holding some oatmeal, in case you're not sure what she means by some hot cereal, like some oatmeal or cream of wheat, something like that. So that's kind of interesting. Well, what if I did the same thing with the water? Okay, I need to figure out a way to divide this so that there would be 4 groups. Okay, so maybe I could think of it in this format, where I break each of these cups of water into 4, and then I give 1 of them to each person. Okay, so these 3/4 would be 1 serving, and then, I could do this in different colors. This, another 1/4 from each cup would be a second person. Another 1/4 from each of the cups would feed a third person, and then 1/4 from each of the cups of water would feed a 4th person. Okay, so in my thinking, I took this 1 cup, which I'm going to cross out because we're kind of looking at this model here. Here's my cereal, here's my water. I'm going to give 1/4 of that 1 cup for 1 serving, and I'm going to do 1/4 of each of the cups of water for 1 person. So how much cereal should she use? Well, we said 1/4 of a cup. Okay? Now, if we look at the water, each person is going to need 3 from each. So we're going to say that they're going to need 3/4 of a cup. The key here to this problem that I really want you to dig into is this idea of 4 servings. Okay? Even if the recipe said something very interesting like, they would need 5 cups of sugar, and these circles just represent 1 cup each, right? 1, 2, 3, 4, 5. 5 cups of sugar. That you need 5 cups of sugar to feed 4 people. How many do you need to feed 1? Well, once again, we said 4 servings, right? So the idea of breaking each of these into 4 pieces would be very helpful, okay? Because then I would say to myself, well, 1 person would be 1 of the 4 pieces. So if you're going to cook this recipe for 1 person, you would need 1, 2, 3, 4, 5 fourths. Okay, you could do that with any number. You could even do that with, let's just say a different number. Like, let's say you need 4 cups of honey to serve 4 people, how many do you need to how many do you need for 2 people? Like, we could even change it that way. So once again, I break it into my 4 pieces because we said there's 4 servings. To feed 2 people, I would then need 2 of them. Okay? Fortunately, 2 of them looks like a what? Half a cup, doesn't it? So to feed 2 people, I would need 1/2, 1/2, 1/2, 1/2. Okay? And you could combine those halves to say that you would need a total of 2 cups. Be totally fine. I'm spending a little time on it because that type of question is really important. The answer is in the details, right? The only way that I can break this up is if I know what the total recipe serves. Yeah, that total recipe serves 4 people. So if we break it into fourths, then we can figure out how to serve each person. The sports store is having a half-off sale where everything is half off its original price. Complete the table below. Show your work in the space beside the table. Original price is on the left. Sale price is going to be on the right. And according to the instructions, everything is half off. The nice part is we've got some even numbers to work with. And for some of these numbers that are a little bit more friendly, let me show you what I like to think of. If you have all of your digits are even, like 84 is, I could say what's half of 8, what's half of 4, and that would be my answer. That works pretty well. Okay? Now, something a little bit more interesting, like 56, it's an even number, but it's an odd tens digit. Well, it's kind of hard to say what's half of 5, what's half of 6. Then that kind of maybe secret math or shortcut doesn't work quite so well. But what I could do is I could say 56 is made of 50 and 6. What's half of 50? 25. What's half of 6? 3. And then combine 25 and 3 to get 28. For some of you who love long division, could I have also done it this way, where I would have said, what is 56 divided by 2? Absolutely. If you're a fan of long division, that works. What do? How many 2's fit in 5? Well, I can fit 2 2's inside of 5, because 2 times 2 is 4. Okay? And then in your long division algorithm, you're going to take 5 minus 4. That gives you a 1. Then you bring down the next digit, which is a 6. How many 2's fit in 16? Oh my goodness, there's 8 2's that fit in 16. And you can double check to make sure this is true, but 8 times 2 is 16. And if you subtract, there's no remainder. So 2 times 28 is 56, or you could say half of 56 is 28. You still get the same answer. Okay? On this next one, and I'm not going to do all of these with you, but on this next one, I want you to think this. Up here we said, what's half of 8, what's half of 4? Well, here I have a number hidden in here that we can say what's half of 12 and what's half of 0. Okay? What's half of 12? 6. What's half of 0? 0. The answer is 60. I could have also covered up the 0 and said what's half of 12 and then put the 0 back on. You get the same answer. Half of 12 is 6. Put the 0 back on. You could also do long division for that. You could use your math facts. It all works. Here, if you're thinking in terms of money, I think you're going to do really well with this. I have 50 cents. What's half of 50 cents? Well, half of 50 cents is 25 cents, right? 2 quarters. Half of that would be 1 quarter. What's half of 40? 20. So my answer would be $20.25. Okay? This one here, just hop down here real quick. I want you to think to yourself, what's half of 4? What's half of 3? And then what's half of 20 cents? Okay? That's going to be your answer here. Now you're going the other way. When you go this way, you have to double. Now you could do that times 2. You could just do $42.50 plus $42.50. Same thing here. You could double the 71 and the 75 to figure out what your money is. Or you could stack and add. One thing I want to point out. If you are going to do this, right, you have to make sure that decimal does not move. So when you bring 5 plus 5 is 10, carry the 1. 7 plus 7 is 14, plus 1 is 15 carry the 1. That decimal is not going to move. 1 plus 1 plus 1 is 3. 7 plus 7 is 14. Okay? If you're going to be stacking and adding, and even if you're going to maybe do standard algorithm for multiplication and double it, right? You are not going to move that decimal. That decimal has to come down perfectly. Okay? Do not change its spot. That's going to change your answer. Okay? Pause this video. Do those questions. Looks like we have Missy's mother owns a pet supply store. Wait, what do we have up here? It says fraction store says I weigh 8 pounds, so I need 2 cans a day. What about me? I weigh 5 pounds, so I need more than 1 can, but less than 2. Can you help me out? We could. So an 8-pound cat. Ooh, I need to learn how to spell. It's a little early for me. That's supposed to say pound. An 8-pound cat needs 2 cans of food a day. Well, help me out here. How much would the cat weigh if it needed 1 can? Well, 1 is half of 2. What's half of 8? 4. So we know that a 4-pound cat, I'll spell it right this time, needs 1 can of food. Okay? So we have a little bit of information to work with. Okay? 1 can for every 4 pounds of cat. Okay? What about me? I weigh 5 pounds. Well, that's kind of interesting because 5 is more than 4, but it's less than 8. And we have some information down here in the question, right? Missy's mother owns a pet supply store. The can of food says that you feed 1 can of food each day for every, oh look, we figured out, 4 pounds of body weight. Missy started to make a table to help people know how much of this food to give their cats every day. And then you finish the table. So, let's do the numbers that we know are going to make sense to us. 4 is 1, which means if I double the 4, it's going to be 2. If I add another 4 and I get to 12, I want to hop over to 12. 1 can for 4, add 4 more pounds, you add a can. Add 4 more pounds, you add a can. So now I would be at 3 cans. Okay? Let's try to find the halfway points. Okay? What's halfway between 4 and 8? A 6 is. What's halfway between 1 and 2? 1.5. Okay? Let's do it between 8 and 12. What number is between 8 and 12? Well, 10 is. What number is between 10 and 3? 2.5. And if you want that to make sense to you, think about this. 1 to 1.5. 4 plus half of a 4. What's half of 4? 2. 2 plus 4 is 6. So that works out. Okay? So half of a can would be for 2 pounds of cat. Okay? Now, we have to figure out what is, so if 5 is exactly between 4 and 6, which it is, what's exactly between 1 and 1.5? And you could think of this in different ways. You could think of this like on a ruler. You could think to yourself, what is exactly between like a number and a half of a mark? Well, it would be a quarter of an inch, right? Well, what if I thought of this as money? What's exactly halfway between, and I'm going to maybe pin this in green, okay? What's exactly between $1 and $1.50? Well, it would be $1.25. If I convert that to a fraction, 25 cents is how much? 1/4 of a dollar. So that would be 1 1/4. Okay? So every time a cat goes up by 1 pound, it gets 1 pound heavier. It's going to need 1/4 of a can. And if you look at this table, you're going to notice that we add 1/4 to every single number. Let's see what happens. 1.5 plus 1/4 would be 1 3/4. How did I get that? Well, it's like adding 25 cents. If I add 25 cents to $1.50, I have $1.75. How many quarters is that? 3 quarters, right? Add another 25 cents, or add another fourth, you get 2. Okay? Now that we have reached our next whole number 1 to 2, you're going to notice that these numbers stay the same. So even though I'm going to change the 1 to a 2, the pattern's going to stay the same. So I had 1, 1 1/4, 1 1/2, 1 3/4. Now I'm going to keep the same fractions. 2, 2 1/4, 2 1/2, 2 3/4. Same thing when I get to 3. I'm going to do the same fractions again. I have 3. Well, I meant to do this in black. 3 1/4, 3 1/2, 3 3/4. Every time you increase that number on the left, you're going to add 1/4 of a pound on the right. And sometimes it really helps to think of it as money because we're only working with quarters here. You know, every time I add a pound, I just add a quarter, add a quarter, add a quarter, and then I get to the next dollar, if that's the way you want to think of it. Well, but when we actually put it in its fractions, we know that 1/4 is 1/4 of a dollar, right? So then we can think of our quarters as fractions of a dollar, or in this case, fractions of a pound, or fractions of a can, and that's going to help our thinking, and then we'll start to see the pattern. Whole number, 1/4, 1/2, 3/4. Whole number, 1/4, 1/2, 3/4. Next whole number, with a 1/4, with a 1/2, with a 3/4. Okay? That pattern's going to repeat over and over. I know I took a little while on this, but this concept is going to come back a lot. It's really helpful if you can dig into it and feel comfy, cozy with it, especially this here. I know I spent a little time on this, but if you look for these details, when you draw your thinking out, it's going to allow you to break those numbers up so that you can work with them a little more easily. Okay? As usual, teachers love to help you with math, and so do your Math Wizard friends and family. Okay? Check you later.